Hey there, y'all. The purpose of this video is to explain how to find limits of two very special types of functions, one called a constant function and one called an identity function. So, a constant function is a function where the function equals a number the whole way around. So this k that's here represents just a number. So it could be like y equals 3, or y equals 1, or y equals 7, and we're interested in finding a limit of that function. Now, the identity function is a function that spits out what it takes in. So basically, the only identity function that's out there is y equals x. So we're also interested in finding a limit of an identity function as x gets close to a number. The reason we're doing this is we're going to use these basic building blocks to sort of build an idea of how to find more complicated limits analytically, so we don't have to find graphs every time we want to find a limit. All right, so I'm going to pop over to Desmos real quick. And the first thing I want to show you is a typical identity function. Sorry, that would be a typical constant function. So this constant function is y equals 1. And you can see that it's the horizontal line y equals 1. Now, if I were to change it just to a different number, it would be a different horizontal line, but they would all be horizontal lines. So let's move it back to 1. Now, if I were thinking of taking the limit as x approaches, say, 2 of this function. As I get close to 2 from the left, the y values pretty much stay at 1, right? And as I get close to 2 from the right, the y values also stay at 1. What if I were trying to approach it from the left, say at -6? It's 1 and 1 from the left and the right. Okay, I could do this several more times. I think you could tell me that no matter where I chose the x to approach, the y value is always going to approach 1, because this is a constant function. The y value is always the same. So if I go over to this, where I was trying to find the limit of a constant function, the limit of constant function is x approaches a of k. Now remember, that k is the function, it's the y equals that number, is going to be that self-same number. So let's make that the same. So that's the first thing. Anytime you're taking a limit of a constant function, no matter what x is approaching, the y value spits out what the constant function was. Okay. Now, an identity function. Now, an identity function looks like y equals x. And we all know what this looks like. It's a diagonal line, slope of 1, passing through the origin. So if I were taking a limit as x approaches, say, 1 of this graph, as x gets close to 1 from the left, the y values get close to, surprise, 1. And as x gets close to 1 from the right, the y values get close to 1 as well. Notice when I'm sliding the point, how the x values are getting closer to 1 and the y values are getting closer to 1. That's the x approaching 1 and the limit approaching 1. So if I were saying limit as x approaches -3, from the left, it gets closer to -3, from the right, gets closer to -3. So I think we could say, if we're thinking about what x is approaching on an identity function, that as x approaches a number, y would approach the same number. And it kind of makes sense if you think about it, because the function itself is y equals x. So if I go to this limit of an identity function and I want to complete this, the limit as x approaches a of x. Now the number we're approaching is a. It's that number, like x approaches 1 or x approaches -3. So this limit would go to a. So the limit of a constant function as x approaches a is the constant itself. And the limit of an identity function as x approaches a of x is a, the number you're approaching. Now we're going to build some more complicated limits off of these over the course of the next couple of days.